Hello and welcome to this video chapter lecture on Chapter 9, which deals with business intelligence systems. And so today we're going to look at how we look for patterns in data, how we find relationships, and how we organize structured and unstructured data. This can come from social media or it might come from data that we've purchased. So this is one aspect of information systems, information technology department that look at data and try and give some meaning to that data. So hopefully by the time we get done with this chapter, you'll understand what business intelligence systems are. They go by BI. You might also see them referred to as data analytics. There's three primary activities for the BI process. We also want you to understand what a data warehouse is compared to a data mart and how organizations are using those. We also want to look at some techniques for processing BI data. Keep in mind, data now is coming in from just about every device that's connected to the internet. So all those devices are generating vast amounts of data, and so somebody needs to be able to organize that data, analyze it, and see what it's telling us. And so a lot of the BI task and technology is there to support, the marketing technology. And so we're looking at different marketing campaigns. How do we analyze if those campaigns are working or not? And so we're gathering a lot of that data. A lot of that data will be coming from, say, Google Analytics. So as managers someday, you need to realize where the data is coming from. Some of the data is generated internally, and those are your operational databases. Some of it is coming from social media, so that would be considered your social data. Other areas you might want to purchase data. Maybe you're purchasing it from a government census or specific data that somebody else has collected and organized. I know there's some hospital data out there that you can actually have access to, and you'd have to purchase it, but then it would give you access to data that maybe other people wouldn't have, and you can analyze that. There's also data that comes from your own employees, and you want to try and capture that somehow so that it becomes some kind of institutional record so that other people aren't learning from scratch every time they join the organization. And so as you can see, as data comes into the organization, somehow it's got to be processed and analyzed, and that would go to a business intelligence application. So applications that you might be familiar with might include SPSS or SAS. Now I know in our department we also have a class called data mining. It's a foreign level class, and the tool we use in there is called Rapid Miner. And then we have a advanced class for visualization, and so the tool in there is called Tableau. And so those would be examples of your business intelligence applications. And then the people that are using the data and also manipulating the data are probably known as knowledge workers. And so over the last 20 or 30 years, we've had that shift from manufacturing workers to more knowledge workers that are dealing with data. And so that's what this whole chapter is about, is dealing with the data within organizations. So moving on, we have some slides from the book here in terms of how the data can be used in business intelligence. One is in the informing area, and we're using that prod example from the beginning of your book, and then the Falcon security example. So when it's informing, we're looking at doing things like a comparison, and then that data then feeds into the next step, which is deciding on what to do. So for the Falcon security example, we have which drones and equipment are in need of maintenance. Well, the only way you'd know if they were in need of maintenance if you were tracking when they had the last maintenance. So how long has it been? How long does something actually last? You can actually then use the data to predict how long something will actually last, and then do a maintenance on that before it actually breaks and causes problems. And so that would help save the company money. This deciding then also feeds into the problem solving. Um, and so again, how can we save costs by rerouting drone flights? So it might be that they're tracking where the drones are flying, and they might see a easier path to send one drone to another area instead of sending two drones to two different areas. And then lastly, the problem solving then feeds into project management. So what you've got here is some sort of hierarchical way of using that information within the organization. So here, using for project management, Falcon Security would be looking to expand geographically. In that case, they're looking how well they've done in one certain geographic area, and then looking at data that would help them predict how well they might do in another geographical area. So some questions that you might be asking is, what are some uses of BI? One is identifying changes in purchasing patterns. And so you're looking at this data and seeing what people are buying. Are they buying any items that go together? Are there life event changes, what a customer buys? What happens if, a spouse should die? Are they then buying additional items or different items? And all that can be tracked or categorized into these different types of customers you might have, and then you can target those customers with the types of sales that you might want. Business intelligence used in entertainment. They're watching what you're listening to, what your rental habits are, and then they can use that then to classify you into a category, and then suggest other products that other customers have bought that are in the same category. So again, helping to increase sales, or just providing you with some alternatives that you may not have been aware of. And so that builds sort of loyalty with the company, and that'll keep you as a loyal customer and not try and venture somewhere else. In terms of using business intelligence in the medical area, if you have a system that's set up, then it might give some real-time injection notification to doctors during an exam. So if that's set up on their system, when a patient comes in, it can look at their records and say, well, they haven't had these shots in a while, or they need these new shots, and tells the doctor right away as it comes up, and then they can get the shots instead of having to send out a reminder and the patient has to come in at another time. And so that helps increase revenues not only for the doctor, but saves time for the patients. So if you look at these as a whole, then a lot of BI is used for classification and prediction. Can we group the data together somehow so that we have similar patterns in that? And then can we predict what they're going to be able to do in the future somehow? So moving on to question 2 is what are the 3 primary activities in the BI process? And so those activities are, you need to acquire the data somehow, you do some analysis on it, and then you publish the results. In terms of acquiring the data, the activities then that they do would be, they need to find the data, they need to clean the data in terms of, are there any outliers, are there data that doesn't make sense, did somebody enter the wrong number, those sort of things. Then they need to organize and relate the data somehow, and that's usually done through maybe some sort of statistical package, and then they need to then catalog it and save that output or that report, or organize the data in such a way that it can be used by somebody else or do the next step in terms of perform analysis. And so here they're going to do some kind of data mining and maybe think of this as big data, where there are certain techniques that you can use for, millions and millions of records, where you have large amounts of data, and then everything would be significant there. And so how do you deal with that data to make sense out of it? Then lastly, they want to publish those results, and so they may have access to different types of servers. Here we show a web server or a report server, or maybe there's some sort of automation. I know I've seen reports here at the university. They've automated a lot of the reports that chairs can look at. We can see, graphically how many students came from which high schools in the states, how many people came from out of state, what their majors are, what their ACT scores are as a whole. So it's not down to the individual person. It's again looking at the data that's been aggregated, and then look at the different categories of what you might have. And so again, you're dealing with those knowledge workers, and you'll notice that with the knowledge workers who's using this information, there's a push or pull technique. And so that's a concept that came out of the internet use, in terms of if they're pulling, then they have to go out and find that business intelligence report, and then they grab it and download it. If it's being pushed out to them, it means that they're not requesting it, it is actually being sent to them automatically. And so it just depends on how you set up on how you want to use your data and the results of that data in your organization. So here's an example of a pool type of operation, in terms of somebody has wanted some data that's sitting out there, and this is data in a database, and they're going to perform a query. And so this is what the IS department might do for them. So in terms of what you're looking at, we have, and this is how it's written out, a nomenclature. We have a table called sales and a table called part. And you can think of each of these tables as something that has rows and columns similar to a spreadsheet. And so in the first table, we have the following fields that contain information. So customer name, contact, title, so on. Then we have part, and it contains part number, shipping weight, and vendor. And so those two tables are related or can be linked through the part number. So if I have a part number in sales, I can link it to this part table and find out what the shipping weight was and the vendor. And then depending on whoever's wanted data from these two tables, I would then generate a report for them. And so in this case, you see what that report would be, and they'll probably do some kind of analysis of the revenue. So if you think about it, we might have, here's customer name, contact, title, bill year, number of order, units, revenue, and then the source. And if we wanted more information, we would link it up to this. So as we get into Access, that'll become clear in terms of generating those query reports. So here's an example of what the part data might look like. So there is an ID, hold on. There's an ID number. That's the primary key, something that uniquely identifies the record. The part number, shipping weight, vendor, so on. And this, if this was, it looks like it's an access table. What this means is that I could add another field here if I went back into the structure of this table and did that. And so if we were extracting information out, this is what the IS people would have to do. So we would get the part data, we have an order extract, we can get that information, and then we would set up some kind of query. This is a query by example type of operation, and you can see which fields out of these tables I'm actually pulling. So most of them are out of order extract, which is this table. And then I've got the part data that I'm wanting that as part of the report as well. And then the vendor part data, and then I can do some kind of criteria limiting to just what I want in terms of the vendors that are out of it. So here's what the report would look like, and you'll notice that they've kind of highlighted over in blue what data came out of a different table, the part data. Also notice that we're missing some data here. It wasn't either filled in or it wasn't available, and so you won't be able to use that information if you wanted to later on. There's also some other problems here in terms of, notice this 0 here. 0 units were sold here, and so that means that that data is incorrect. So somebody's going to have to clean that up. Again, that's what the IS people will do, or if you're in data analytics part, that's the first part of what you'll do, is clean up the data and make sure that it's accurate so that other people, when they're using it, are making good decisions with that. Here we have an example of doing a summary query, and here you'll notice that we've got the field names that we want out of this table, so we're only using one table. Notice that in this last column we're actually building a formula, and so we call that an expression here, but it's built on the field names that are in this particular table. Then also notice that we're doing some aggregate type of functions here, things that we did in spreadsheets, but this one happens to be in a database. So we're actually going to sum the revenue, we're going to sum the units, and then get the average price on that based on knowing the revenue and knowing the sum of the units. So then the output then would look something like the following. And again, it's just all the field names that we wanted out of that table, so we don't have to show to the worker all the data or all the field names that are there. Notice that it has some generic field names at the top when we're doing a sum. The average price was the name that we created for the expression and how it's listed. So we'll have to go back and format this a little better for reports. We may change the name here so that it reads a little easier. Here's an example of qualifying the information that you have depending on which table that it comes out of. And what I mean by qualifying here is that you are wanting certain criteria or matches based on each of these fields. So the number of orders that I'm looking for has to be greater than 50. The average order size has to be less than 2.5. The unit prices are less than 100, and the shipping weight is less than 5. So this is very similar to the criteria that we see in an Excel database in terms of all these numbers being on the same line. They represent an AND condition. So each condition has to be true in order for the entire record to match and be pulled into our report or output. Again, here's the output for that. It's just a result of what we were looking for, and so everything should match up. Again, we'll have to do some formatting for the report, but these are the sort of things that the IS department would do, or if the knowledge worker had enough skills, they would be pulling that information themselves out of the databases. And so here is the final results then of the total orders, the total revenue, and the part numbers that we produced. people would then use this information to make decisions. So it might be that they look at these certain part numbers and they decide, is this a something that we might want to design ourselves. And so if there's not enough revenue to be generated in these type of parts, then they probably wouldn't do it. Versus this part up here, there might be enough money to be made in order to develop that part. All right, so I'm going to pause there, and so when we come back, we will start on question 3.